Hi children, in probability we have seen probability distribution. That is a general approach to find out the distribution. Now we will take a particular case of probability distribution, that is binomial distribution, which is a discrete random variable will be acting here. Now in exam when you get a question, we will not be able to identify whether I should use purely probability distribution or can I take the help of binomial distribution formula. For that you should know properly when I can use binomial distribution formula. For that only I tell these conditions. If these conditions are met, what I am going to speak, then you can use this binomial distribution formula. The condition number 1 is the number of trials that you make in an experiment should be finite, and if possible let it be decided first itself. That means I will throw a coin 5 times, 10 times or 6 times, something like that. The second thing is the number of outcomes that is coming from an experiment should be exactly 2. I'll tell you an example. When you throw a coin, you have head and tail. There are only 2 outcomes. But if you throw a dice, you have how many? 6 outcomes. Not 2 outcomes. There are 6 outcomes. But if you can classify them as 2 outcomes, then we can go for this binomial distribution. For example, I'll tell when I throw a coin, I am looking for odd numbers. So what is not odd is even. There are only 2 categories. I can categorize the whole population in the world, those who are aged above 50, below 50. See, there are only 2 categories. If you look at in your school, there are many categories, first standard, second standard, likewise. So this all you should be able to. We divide the part into one which is favor, one which is not in favor. Like that, if you can divide, that is the second thing. And the next thing that you should check is that the probability of what you favor, let us call it as a success. What you look for, we will call as a success. What you don't look, or what is the opposite of what you look, is failure. Usually it is represented by the small letter P and Q. Okay. So what I am saying is the probability measure only is P. That P should be a constant all through the trials. For example, if I throw a coin, I get a tail. What is the probability of getting tail? 1 by 2. Again, if I pick and throw it, again it will be 1 by 2 only probability. N number of times you try, the probability of getting tail doesn't change in a coin. But there are situations, if I have a 52 cards, I want to take a black card. First I take a card and I keep it away. Again, if I go for taking a black card, the probability has changed. First it was 26 by 52. Now one black card is lost. Now it is only 25 by 51. Then it will be 24 by 50. Likewise, it will get a change every case, this one experiment, or every one after the other. This is what we say with replacement, without replacement. I don't replace the card back. Therefore, the base of that what I is looking for is changing. So when it changes, therefore it is not, in fact, they are not independent events. The events should be independent. In another way, the short way we can say, if the events are independent, one doesn't affect the next one, then you say that is another condition that is met for binomial distribution. So these are n should be finite and defined. Each trial has 2 outcomes only. That is, one is success and the other is failure. Success doesn't mean that it should be positive thing. Sometimes negative things. You will see some cases of selecting eggs, good eggs and bad eggs. If you are looking for selecting bad egg, then the success is getting bad egg only. So therefore, it doesn't literally meaning that success and failure. What you look for is success. What you don't look, or the opposite part, is the failure. And the result of any trial is independent of the previous trials. The probability of success doesn't change. Therefore, probability of failure also doesn't change. And another thing that you should understand is this P plus Q will always be 1. Because the total probability will be 1. The probability that tomorrow I go to school I don't go to school. If you add both, if I go 70% chance, 30% I don't go. But if you add them, it is 100%. So P plus Q is 1. Now, if these conditions are met in a situation, we will work out some questions. If these conditions are met, then you can use a formula which will make our work easy. What is that formula means? We will have success, many success. There may be some number of failures. Okay, if this success means this is P into Q into Q into, this is how we take the probability. Probability of this, probability of something and something and something, then it's multiplied. So the total, suppose there are n events are there. And if there is R success, then this P will become P to the power R. And then Q will be what? What is left over? Total is N. R is success. Then what will be failure? N minus R. N minus R will be failure. Therefore, Q will get N minus R. So, this product will give you the probability of one happening and one not happening. So, there are different combinations are there. So, we will say NCR P to the power R, Q to the power N minus R. This will be the probability of X equal to some R. So this is what we are going to take as our formula. Probability of X equal to R is NCR into P to the power R, Q to the power N minus R. Where P and Q are the probabilities of a success and failure. So if this is 0.5, this will be also 0.5. If this is 0.6, P is 0.6, this will be 0.4. If this is 1 by 3, this will be 2 by 3, because 1 by 3 plus 2 by 3, P plus Q should be 1. So if you know probability of success, then you know the probability of failure also. If 1 by 6 is success, 5 by 6 will be failure. And what is N? The total number of trials. That I already said in the question, it will be given how many trials are happening. And R is what you look for, how many success you want, that is what R is. So depending upon that, this situation will become more effective when you work out some question. Okay, I'll write one question here. These are the conditions which you should keep in mind. Okay, let us write a question based on this, and then we will discuss. We will do more questions in the coming videos. So first question is, this is important part only. A die is thrown 6 times. This is the question. A die is thrown 6 times. Getting an odd number is a success. Getting an odd number is a success. What is the probability? What is the probability of question number 1? 5 success. Question number 2. At least 5 success. Question number 3. At most 5 success. So let us work out this question. And there is one question. Last question is no success. Fourth question is no success. Let us understand this situation. How do I understand this situation is, first in exam when I get, since I have written here binomial distribution, we may say it's binomial distribution question. But in exam, you don't have a heading like this, binomial distribution. So, but we will identify, how we identify? Let us look at, they said a die is thrown 6 times. Okay, see, n is finite. 6 times only they are throwing. It's definite number of times it's thrown. Getting an odd number from a dice is called success. You know, in dice you have 1, 2, 3, 4, 5, 6. They are the 6 outcomes. 1, 3 and 5 are odd numbers. What is left over? They are even numbers. So there are only two categories, odd numbers and even numbers. So second condition also satisfied. And if you throw a die n number of times, take and throw, first throw doesn't affect the second throw. They are independent events only. So the P is constant here. We'll find P and Q first. We'll write n is 6. And what you look for is R is 5 success, at least 5 success, at most 5 success, no 0 success. That's all our R value. So let us use this formula and work out. And I will write first P. P is when you throw a dice, you get what's odd number as a success. How many odd numbers are there? 3 odd numbers are there out of 6. So the probability of the P value will be 1 by 2. Therefore, Q also will be what? 1 minus 1 by 2. That is also 1 by 2. Or you can write that also 3 by 6 because 3 even numbers are there. And N is what? N is the total number of, that is 6. Now the only thing that you need is R. R depends upon each question. Let me take first question. First question. We will say R is equal to 5. So we will write the formula. Probability of X is equal to 5 is NCR. NCR means here N is what? 6. So 6CR is 5. What is P? P is, remember the formula? Formula is NCR P to the power R Q to the power N minus R. This is what I fill in. So 6C5. P is what? 1 by 2 to the power what? R is 5. Then 1 by 2 only success and failure both are. This will be but 6 minus 5. 6 minus 5, that is 1. So this is, you should know 6C5 is what? 6. Remember, NC, N minus 1 is what? N. Therefore 6C5, the consecutive numbers if it comes, this bigger one will be the answer. So 6 into, this will become 1 by 2 to the power 6, 5, 5 plus 1, 6. So this will become 6 by 64 or that is 3 by 32. So first question over. Okay. Now we will see what is the at most, second question is at least 5 success. At least what is probability of at least how many success? 5 success. What do you mean by at least 5? At least 5 means minimum 5. It can be more than that also. So this means probability of 5 or 6 or more than that, but more will not come because you are maximum you are throwing only 6 times. So 7 doesn't come. So this means, or means you have to add probability of X equal to 5 plus probability of X equal to 6. So let us use the formula. So 6C5, 1 by 2 to the power 5, 1 by 2 to the power 6 minus 5, 1, plus 6C6, 1 by 2 to the power 6, and 1 by 2 to the power 6 minus 6 is 0. So when you calculate this will be 6 into, this will become 1 by 2 to the power 6 plus 6 is 6, NCN is 1, NCN is 1. So this will become 1 into 1 by 2 to the power 6. So when you add this one, this is 6 by 64, 1 by 64. This is 1 by 64. So 6 by 64 plus 1 by 64 will become 7 by 64. So this will be the calculation for probability of at least 5 success. Now let us do another, the third question, that is, we will say the next question is, we have at most 5 success. Let me do it here. Sorry, I erased this one. Okay. At most 5 success. Probability of at most 5 success. At most 5 success means maximum you can have 5 only. So it can be 0, 1, 2, 3. This means probability of X equal to 0, 1, 2, 3, 4, 5. But this is a lengthy work. You have to do probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to this, like this, fully you have to do. So what we do is we know total probability is 1. So total probability is 1. From 1 you subtract the opposite of it. So what is opposite of this? Opposite of this is probability of x equal to 6. Probability of x equal to 6. So this will do it as 1 minus probability of x is 6 is 6 is 6. 1 by 2 to the power 6. 1 by 2 to the power 6 minus 6, 0. So this is 1 minus, this will be 1 by 64. So this will become what? When you do, this is 63 by 64. And there was a last question, probability of no success. Probability of no success. That means you need to find probability of x equal to 0. That will become what? NC0. That is 6C0. 1 by 2 to the power 0. 1 by 2 to the power 6 minus 0 is 6. So this will 6C0 is 1. Like NCN, this is 6. So NC0 will also be 1. So this is 1 into, this is also 1 into 1 by 2 to the power 6. That is 1 by 64. So we got the next situation also, these 4 questions. This is how we go about the approach of doing a probability, finding probability distribution with the help of binomial distribution when the conditions are met. So in exam, when you get a question, you analyze whether we can use binomial distribution formula. What is that formula? NCR, P to the power R, Q to the power N minus R. If we can use that, go ahead with that. Otherwise, we will have to go back to the first method itself. For example, without replacement questions, we have to use probability distribution direct probability finding method only. Okay. We'll do some more questions based on this.